你这个你刚刚发我的这个表格是只有T17的吗？还是它俩都能用？就再加上2、3只是吗？你
Hello friends, welcome to our new broadcast. I'm Jade. Today's new stream focuses on core topic methods for detecting and treating defects in tunnel secondary lining with the continuous advancement of transportation. In first schedule construction, tunnel projects are increasingly common. As a requirement of the tunnel schedule, the quality of the secondary lining directly impacts the safe operation of the tunnel due to various influencing factors. The secondary lining is prone to different types of defects, such as cracks, water leakage, spoiling, and walls. Therefore, it is critical to accurately detect tunnel secondary lining defects and take effective measures to address the two types of tunnel secondary lining defects. These defects not only affect the tunnel's appearance but also seriously threaten the schedule safety and survival life of the tunnel. Firstly, I will introduce the types of these defects. 1.1 Cracks. First, temperature cracks. Temperature fluctuation inside the tunnel is a significant factor causing these cracks. During the day, temperatures inside the tunnel may rise due to external air temperature, operation of construction equipment, and job at night. The thermal examination and construction characteristic of considerate cause is to be repeated stress unprepared during these temperature fluctuations. If the temperature variation range is large and frequent, the stress generated within the considerate axis is decibel strength, leading to temperature cracks. Sewerage cracks during the handling process of considerate generally outflows and settlement undergoes hydraulic, both leading to warm shrinkage. If this shrinkage is restrained by formwork or previously set considerate preventing free contaction, shrinkage cracks will form in secondary line construction factors like the considerate mix. Propagation and pouring methods can influence the occurrence of shrinkage cracks. For instance, considerate with a high water sentiment tends to have more pores left after and container shrinkage, making it more to shrinkage cracks. 3. Differential settlement cracks. Uneven settlement of the tunnel foundation subjects the sectionation line schedule to uneven stress. The globally conditions where tunnels are located are often complex and variable, particularly including soft soils, dry rock zones, and other unfavorable ground conditions with uneven bearing quantity. After tunnel compaction, the foundation may undergo different settlement. If the settlement difference is significant, the secondary lining schedule experiences stress like twisting and stressing, resulting in cracks. 1.2 Construction quality-related cracks. First, improper considerate exploitation, incorrect retards or compact arrangement, sand and water affect the strengths and properties of considerate. For example, insufficient settlement results in inadequate considerate strength, making it poor to occur under extreme laws, and excessively high water increase workability but reduce strength and increase shrinkage, also leading to cracks. 2. Inadequate compaction during pouring. If wheels remain inside the considerate, this device reduces the interface and the strength of the considerate. Under external loads, cracks are likely to form at these weak points. Additionally, overly fast pouring speeds or unreasonable pouring sequence can also lead to inadequate compaction and subsequent breaking. 3. Inadequate curing. Considerate requires proper curing after placement to ensure normal strength development and stability. If the curing initiation is insufficient or methods and improper, surface are too quickly causing required international moisture loss and leading to shrinkage cracks. 1.3 Water leakage. First, sidewall leakage. The sidewall where the secondary line contacts the surrounding rock is a common location for water leakage. Causes may include improper installation of the waterproofing, such as insufficient overlap width, incomplete widening of system, or in-situ blasting, blowing groundwater to preventing the secondary line at connections or damaged areas. Additionally, inadequate considerate wobulation compaction or exciting in the sidewall area can provide pathways for water. 2. Settlement joint liquid. Settlement joints are designed to economic formations from foundation settlement. Temperature changes during the tunnel's surface life. Leakage at these joints can occur due to impositions of water stops, gaining of water stops, or furniture joint sealants, improving handling during construction, such as not to design specifications or substandard workmanship, can also cause settlement joint leakage. 3. Inward construction joint leakage. The inward is the bottom schedule of the tunnel and its construction joints are poor to liquid. This is primarily because treating construction joints in the inward is challenging, and considerate placement is susceptible to inadequate compaction. Furthermore, groundwater pressure is often higher at the inward. If waterproofing measures at the construction joints are inadequate, groundwater will slip into the tunnel entering through these joints. 4. Earthquake leakage. The earthquake is the top schedule of the tunnel. Due to its everyday position, construction is difficult, and ensuring considerate placement quality is challenging. If was inadequate competition or other defects exist in the arch considerate, or if the water pouring is not lead smoothly or flex. In this area, leakage can occur. Additionally, significant surrounding rock pressure on the tunnel roof consequences the secondary line, winding cracks and defects in the arch cone and leakage. 1.4 Boyoun. First, insignificant or considerate strengths. Considerate strengths is a key indicator ensuring the stability and durability of the secondary lining schedule. Factors like import max protection standard, quality or uneven maxing can lead to insufficient strength. Durance-wise, the secondary line bars rose from some reading rock pressure. If the considerate strength is inadequate to withstand those loads, spawning occurs. 2. Physical cycles in cold records, the secondary line is affected by cells. In winter, low temperatures cause water within the considerate to freeze and expand, damaging the considerate schedule. When temperatures rise in spring, the ice melts and water falls. The process again repeated freeze-thaw cycles accumulate. 3. Chemical ocean. The tunnel environment may contain harmful substances. They can reach chemical with comments in the considerate, generating expensive products that considerate international and damage the considerate schedule. For example, which with the chemical viaduct in considerate to form, which can combine with water to form cistern. The worst explanation of gasm cause creeks and spawning. Additionally, combination reduces the considerate and the passive film on reinforcing steel and leading to considerate, which subsequently causes boiling. 1.5 Ways. First, inadequate considerate competition during considerate pouring, insufficient burning time. Other factors affecting placement quality, such as poor considerate workability or expensive pouring spend, can also cause waste. 2. Formwork deformation. Formwork shapes the considerate during placement. If the formwork lacks significant has inadequate support or it is subjected to international impact during construction, it can deform. Deformed formwork prevents considerate from fully filling the intended space, resulting in walls. 3. Detachment. Detachment between the international support and the secondary lining is a common cause of waste. Factors like an uneven internal support surface or uneven thickness can create gaps between the international support of the secondary lining. If these gaps are not dilated and addressed during secondary lining considerate placement, detachment causes shrinkage of the secondary line considerate during setting can also cause detachment from the internal support. 3. Understanding the types of defects is the first step to ensure the long-term health and safety of a tunnel. A set of significant and reliable methods is essential, currently and approved. Detecting these hidden is key to ensuring tunnel safety. In the next article, we will detail the detection methods for tunnel secondary lining defects. 3.1 Visual inspection is the most fundamental method for detecting disease in tunnel secondary linings. It involves the visual observation of surface defects such as cracks, water leakage,